This is 2023 question number 8. Let us try to go ahead and see what this question is saying. It says find eigenvalue and eigenvector of the following matrix. Is the above matrix diagonalizable? If so, find a suitable matrix P. Let us start by finding a characteristic equation of this matrix. So this is very simple. You will go ahead and you will do A minus lambda I determinant equal to 0. Notice that you're given this as your matrix A, right? So if I just go ahead and do minus lambda I will get my characteristic equation. So it will go ahead and become 1 minus lambda 0, minus 1, 0, 2 minus lambda minus 1, 1 minus lambda determinant equal to 0. Now, when you will be going ahead and you will be solving this, you will get 1 minus lambda square, 2 minus 2 lambda minus lambda plus lambda square minus 1 plus 1 minus 1 plus lambda is equal to 0. So you will get 1 minus lambda square minus 3 lambda plus 1 minus 1 minus lambda is equal to 0. You can take 1 minus lambda common. This will give you lambda square minus 3 lambda plus 1 minus 1 equal to 0. So 1 minus lambda into lambda minus 3 equal to 0. So lambda will have three values, 1, 0, and 3. These are the three eigenvalues of this matrix. Now what we can go ahead and do? We need to go ahead and find the eigenvector. So we will start by taking lambda as 0. So again, Ax is equal to lambda. I will start with this. So my matrix A is 1, minus 1, 0, minus 1, 2, minus 1, 0, minus 1, 1, x, x1, x2, x3, lambda, 0, 0, 0. So I will go ahead and get x1 minus x2 is equal to lambda, minus x1 plus 2 x2 minus x3 is equal to lambda, and x2 minus x2 plus x3 is equal to 0. Now from the first equation I get x1 is equal to x2, and from this equation I get x2 is equal to x3. And if all three values are equal, this is automatically satisfied. Okay? So I can say therefore my eigenvector x looks for the form that the only thing I require is that x1, x2, x3 should be equal to each other. They can be any k such that k belongs to R. Just that this have to be equal to each other, right? So if x1 is k, x2 is also k, x3 is also k. Now what you can start with is the second equation, second lambda. So you can go ahead and take lambda as, when lambda is 1 now, I will get again Ax is equal to lambda x I have to do. So A minus lambda x have to be 0. This was not required here, beta. मतलब lambda x ही है, but actually lambda is 0 है, तो कोई फर्क नहीं पड़ रहा था. That is why I just wrote 0 there. So this will be actually that in my this matrix, है ना, ये जो हमने matrix create किया था, everywhere I will put lambda as 1 now. So I will go ahead and I will get 0, minus 1, 0. Minus 1, 2 minus 1 will be 1, minus 1, 0, minus 1, 1 minus 1 will be 0. And then I will just go ahead and put x1, x2, x3 equal to 0, 0, 0. So I will get minus x1, so I will get minus x2 is equal to 0, minus x1 plus x2 minus x3 is equal to 0. And minus x2 is equal to 0. So this is for sure that something that I have got from here is that I will have x2 as 0. This is for sure. And if x2 is 0, I will just put 0 here. So I will get minus x1 minus x3 is 0. And this will mean that minus x1 is x3. So x1 is minus x3. So my eigenvector in this case looks something like this. That x1, if I just put x3 as 1, x2 is 0, x1 will be minus 1, and then it can be multiplied with any scalar, right? So this will be my eigenvector, multiplied with any scalar. Alternatively, you can write your eigenvector as this also, that x1 is 1, this is 0, This is -1 and it is multiplied with any scalar. Now on very similar basis, beta, you need to go ahead and you need to take lambda as 3. So third part where you will be taking lambda as 3. Again, ax is equal to lambda x. So a minus lambda I into x has to be 0. So everywhere instead of lambda, अब आप डालोगे 3. Here you will put 3, here you will put 3, here you will put 3. So when you will go ahead and do that, what will happen, beta? What will happen to your matrix? देख लेते हैं. Let us write down that matrix here itself. So we will go ahead and we will get 1 minus 3. That means -2, -3, 0, -1, 2 minus 3, -1, -1, 0, -1, 1 minus 3, -2, into I will get x1, x2, x3 is equal to 0. So now in this case, beta, what will happen? -2 x1 minus 3 x2 is 0. Minus x1 minus x2 minus x3 is 0. Minus x2 minus 2 x3 is 0. Right? 3 equation, 3 variable, you need to go ahead and solve these equations. So from this equation, you will get x2, you will get x3 is equal to minus x2 by 2. And from this equation, you will get x1 is equal to 3x2 by -2. So just put these values here. So x1 will be minus 3 by 2 x2 minus x2 minus x3 will be minus x2 by 2 equal to 0. So when you will be solving this, what will be the value of x2 that you will be getting? So you will get x2 is going to be 3 by 2 x2 plus x2 by x2, 4 by 2, 2 by 2 x2, x2. x2 will be coming out as 0 in this case. x2 will be coming out as 0 in this case. Right? I hope we have done this correctly. Correct. -2 and this is minus lambda, so minus x3, minus 3. Just let's verify whether this was minus lambda only. Where is our matrix A minus lambda I? So here I think we didn't have lambda. Here we had just -1 beta. Right? Here we just had -1. Right? So, yes. So this will be just -1 that I will be having. So this will be -1. Right? This will be -1 that we will be getting everywhere. Yes. This was -1 that we had. Yes. Okay. So from that analysis, if I just try to solve this, so this will be -2x1 minus x2 equal to 0. So from here, my x1 will come out as x2 by -2. So -1 by 2x2. Right? And the second one will be minus x1 minus x2 minus x3 is equal to 0. And the third one will be minus x2 minus 2x3 is equal to 0. So from here, your x3 will come out to be minus x2 by 2. Your x1 will come out to be minus x2 by 2. And if I just go ahead and put it in this equation, I will go ahead and get minus x2 by 2 minus x2 minus, instead of x3, I will just go ahead and put minus x2 by 2 equal to 0. So this will give me x2 by 2 minus x2 plus x2 by 2 equal to 0. So 2x2 by 2, which means x2 minus x2, that means 0 is equal to 0. So this is always true. So we have got nothing as of now, right? This is always true that 0 is equal to 0. So now what we need to go ahead and do, therefore, we need to just assume some value of x2. So let's say that I assume that x2 is equal to some k. So then x1 will be minus k by 2 and x3 will be minus k by 2, right? So from here, we can write down our matrix that if this is k, this will be minus k by 2 and this will be minus k by 2. I can multiply with 2 throughout and I will get that this will be minus k, this will be 2k and this will be minus 2 minus k, right? So what has happened therefore is that if I take k common, I will get minus 1, 2, minus 1 and this would be my eigenvector 3. This would be my eigenvector 3, right? So this is how you can go ahead and find the eigenvectors in this case. Okay. Now what you can go ahead and do is, if you need to go ahead and find out if the matrix is diagonalizable or not, I'm just telling you how to do it. You can go ahead and find P inverse A into P, right? When you will find this matrix, if the diagonal elements are eigenvalue, then it is diagonalizable, otherwise not. In particular, you will find that P inverse AP will come out to be 1 by 4, 0, 0, 0, 0, 0, 0, 0, 0, 18. So since the diagonal elements are not eigenvalue, it is not diagonalizable. Okay, beta, thank you.